Hello students, welcome back. Let's take up another question, and this is from the year 2025 board question, and this question is of 3 marks. The question is, consider the following electric circuit, calculate the values of the following: the total resistance of the circuit, the total current drawn from the source, and the potential difference across the parallel combination of 10 ohm and 15 ohm resistors. So here we have been given a circuit in which there are 4 resistors, out of which 10 ohm and 15 ohm are connected in parallel, and a 60 ohm and a 40 ohm resistors are again connected in parallel in the circuit. Now we have to find out the total resistance of this circuit, the total current drawn as a result of the equivalent resistance produced by all these resistors, and then we have to find out the potential difference across the resistors 10 ohm and 15 ohm. So let's find out. So first we need to find out the total resistance of the circuit. Now the total resistance of the circuit will be equal to the equivalent resistance of all these 4 resistors. Now you see in this part, let us name this part of the branch as R1 and this part as R2. Now R1 has 2 resistors 10 ohm and 15 ohm connected in parallel. So let's find out the equivalent resistance of R1 and then we'll find out the equivalent resistance of R2. So for R1 we have 1 by R1 is 1 by 10 plus 1 by 15 because these 2 resistors are connected in parallel. Now either you can find out the LCM of these 2 numbers or simply you can write them 10 into 15. So here 10 gets cancelled. It's 15 plus 15 gets cancelled. It's 10. It's nothing. You can simply find out the LCM. I am writing it in this way just to make it simpler to reduce later on. So it's 25 by 10 into 15. So here 5 5s are 25, 5 3s are 15 and here 5 2s are 10. So it's 1 by 6. So the equivalent resistance R1 is 6 ohm. So this equivalent resistance is 6 ohm. Similarly, let's find out R2. So 1 by R2 is 1 by 60 plus 1 by 40. Again, find out the LCM and write, or simply write it as 60 into 40. So 60 gets cancelled. It's 40 plus 40 gets cancelled. It's 60. So the LCM is 100 by 60 into 40. So 0 gets cancelled. It's 1 by 24. Hence R2 resistor is of 24 ohm. So the equivalent resistance of R2 is 24 ohm. Now R1 and R2, you see they are connected in series in the circuit. If this one is R1 and this is R2, you see it is connected across the same branch. So the two are in series. So let's find out the equivalent resistance of the series circuit. So let this series part, I write it as R simply. So it is R1 plus R2, which is 6 plus 24, that is 30 ohm. Hence the equivalent resistance of the entire circuit is 30 ohm. So this is the answer to bit 1 or bit A. Now we'll find out the total current drawn from the source. Now for finding out the total current drawn, we have to apply Ohm's law. So let's apply Ohm's law and find out the current drawn from the source. We know that the total resistance of the circuit is 30 ohm and the value of the potential difference of the circuit given over here is 15 volt. So I write here as 15 volt. Using Ohm's law, we can find out the current in the circuit. So V is equal to IR from Ohm's law. So I will be V by R. Now the potential difference given over here is 15 volt by resistance given over here is 30 ohm. So it's 1 by 2. So the total current drawn from the source is 1 by 2 ampere or 0.5 ampere. So this is the answer to the second bit, that the current drawn is 0.5 ampere or 1 by 2 ampere. Now let's find out the potential difference across the parallel combination of 10 ohm and 15 ohm resistor. Now to find out the potential difference across the parallel combination of 10 ohm and 15 ohm resistor, that is this part. Now we know the equivalent resistance of this part, R1, we got it as 6 ohm. Now the current flowing in this circuit, we got it as 1 by 2 ampere. So we need to find out the potential difference across this end. So potential difference, again we'll use the Ohm's law. So V is equal to IR. Now the current flowing through this branch is 1 by 2 ampere. So it's 1 by 2 multiplied by the equivalent resistance of this circuit, that is 6 ohm. So it is 3 volt. So the potential difference across the equivalent resistance of 10 ohm and 15 ohm is 3 volts. So let me write this as Vp, that is V parallel, that is potential difference across the parallel circuit of 10 ohm and 15 ohm. So these are the answers to this question. I hope you have understood the solution to this. If this video was helpful to you, please like this video, share it with your friends and subscribe to the channel. Thanks for watching. Bye bye. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.